Hey guys, getting a lot of questions on number 14. So I wrote this out, thought I would just kind of talk you through it. So they want to know, they want you to solve it using a graphing calculator. You can also do Desmos online and use their graphing calculator function if you don't have a graphing calculator at home. The only trick is if you're using your home one, you got to make sure your window's set big enough so that you can actually see it. Whoops. And so they said, they've given you this equation here. They said n sub 0 is the initial amount, which they told you was 250 milligrams. And basically, you're just plugging that into the equation. That gives you this top equation that I wrote down, n of t equals 250 times e to the negative 0.115 t power. Okay. It looks ugly, and we wouldn't want to graph it by hand. But again, you're just going to use Desmos or a graphing calculator. And so there's a couple ways you can do it. You can either just plug that one into the graphing calculator and use the trace button. And if you use trace button along it, you should find that y is 16 roughly when x gets to about 24. The other way you can do it is you graph that one. You graph n of t equals 16, because that's what we want it to decay to, 16 milligrams. And if you have those two graphs, where do they cross? And they should cross around 24 and 16 is the point. Okay. Later on, we're going to actually learn how to solve those using logs. But for now, that's all they expected you to do with that, was be able to look at a graph. The other part, I think, seems trickier. But if you remember everything you know, they've asked you to find a growth factor or a decay factor. Well, in this case, it's decay because they told us it's a decay problem. So I wrote the equation, y equals 250 times e to the negative 0.115 t power. Again, I just wrote that in blue. And then if you notice, I circled e to the negative 0.1155 power because that is your b value. So that tells you your growth or decay. And remember, that's just a number. I know there's a letter E in there, but remember we talked yesterday, that's a number. So e to the negative 0.1155 power is right around 0.891. I just plugged it into my calculator. Okay. So that means your B value is about 0.891 for looking at real numbers. That's not your decay rate though. So if you remember when we first started talking about this, we said, oh, it's kind of like if you buy something on sale. If you buy something on sale for 20% off, you have to take 100% of the price minus the 20% off, and you're actually paying 80%. Well, the 0.89 in this problem is showing you like what you're paying, even though this is not money and this is not a sale. Okay, but it's the same idea. So if you take 1 minus R, that gives you 0.891. So R is the difference in there. So 0.109. And again, these numbers are a little wonky. We're not using totally even whole numbers like we did in some of our examples. But so your decay rate's about 10.9%. Hopefully that helps make more sense. And you'll be able to do 15. Okay, bye.